material after the initial build and use them to debug the software. One of the things that we want for Debian is that actually we want to be sure that we can build packages from source. That's mandatory, and so if we say that packages need to be reproducible, to have reproducible builds, then we can make sure that actually that is happening. Multi-arc same has to be exactly the same packages across. Multi-arc same packages, if they contain files with the same name, they have to be bitwise identical. So also, while making a package build system deterministic, we help the multi-arc crowd, or vice versa. There's also the idea that if you, from one version to another of a software, if the build system is deterministic, maybe the .deb will not have changed that much. And so between one version to another, then it might be pretty similar, and we might get smaller deltas and faster upgrades and less bandwidth, less disk space. Another uses of deterministic build will be the build profiles mechanism that it's getting in. And so the build profile is an idea, like it's helpful for bootstrapping new architectures. That's one of the underlying reasons. And the idea with build profile is that if a profile A build a couple of packages, like some packages, and if a build profile B build a subset of these packages, the subsets need to be also identical in feature to the other build profile. And so with reproducible build, then we can make sure that they're actually feature-wise identical because they would be bit-wise identical. And maybe we can find other reasons. I don't know. There's many interesting aspects. So how did it start for me? So I'm active in the Tor project. And during past year, spring, Mike Perry and other people working on the Tor browser work on making the Tor browser build process deterministic. For one of the very reason I explained before. That process was partly inspired also by the Bitcoin crowd, because they are shipping binary that handle valuable assets of people, and so they wanted to be sure, like when they hand out a binary to someone, that someone says, yeah, you're not stealing my money, or whatever this cryptocurrency thing is. And so, but it's not. So we have that for the Tor browser, and it's been very interesting in how it changes some of the development processes. So for example, once someone in the team tag a build, then other people in the team will also start running the build, but there's only one person who will actually upload the gigabyte of multiple versions of package to the server. Everybody else will only upload a single signed signature of the checksum file, of the checksums on the various. And so you can actually have one system with a very, that you do not trust that much, but with a very fast internet connection, uploading data to a server somewhere. And then on your own laptop, you redo the build, and you have like you're on a train, whatever. Once the build is finished, you only have to compare the checksums. And if the checksum match, you know that it's okay. And if multiple people do the same process, and you have far more trust, then there have been no compromise in the process, because, well, we all got the same results, and it's highly unlikely that everybody got compromised at once. But this is not a new idea. So someone once, after starting the process last year, someone, Martin Uke, wrote to me and pointed me at that email from 2007, so that's 7 years ago, on Debian Devel, saying, yeah, I think it would be really cool if Debian policy required that packages could be rebuilt identical from source. At the moment, it's impossible to independently verify the integrity of binary packages. Well, that was 7 years ago. the reaction were not super enthusiastic. Also probably because Martin was not part of the established Debian crowd. But so for example, like Neil Williams, who's in the room, no, said, well, I see no benefit. Well, I hope you will see benefits. And Manoj, who's also not in the room, but still, said, well, I think this is technically infeasible, but hey, I'll be happy to be proved wrong. So I would be, let's prove him wrong. So what happened is after the example of the Tor browser, I scheduled a really last-minute buff during DebConf 13 in Switzerland, and I was very surprised because there were like 30 people showed up. And we had an interesting hour-long discussion, well, 45 minutes discussion, which was short, but still. And that kicked off the wiki page Reproducible Builds. And so, well, the wiki page tries to gather many information. It's a long page. If you want to help make it better, please do. But mainly, how do you do reproducible build? What are the steps that we need to do that? So it's pretty simple, actually. One is you record the build environment, so you know what tools you used to build a specific package. And then when you want you need a way to reproduce that build environment. So when you want to reproduce the build, you start by setting up the same environment that was the initial environment. And then you need to eliminate all the unneeded variations that are part of the build process. And so recording is actually fairly simple for Debian. It's, we have packages, they have versions. So if we install the very same versions of the packages that were installed, we are very likely to be in the same build environment. Reproducing the build environment is also fairly easy for Debian because we have snapshot. And snapshot saves every binary version of every package that I've entered the archive. And so you can actually take packages from there and you get an environment that is very close to the initial environment. Then there is all these variations and that are like captured by the build systems where maybe they're not, they don't need to be captured for getting a final software. So timestamps. Everywhere, timestamps. So like, you create a file and then it's the time of its creation is recorded. That's what DPKG does, for example. So let me tell you, I'm willing to lead collective timestamp fan anonymous sessions or whatever, like a support group if you want. Timestamps in a build process are not a useful information to capture. Please trust me. What is interesting is, for example, what source you have used, the environment that you've used, like the timestamp maybe of the last Git commit, but the timestamp of the build, no. If I take an old version and I build it now, there's no interest into capturing that information really. Maybe as a metadata, but it's not as part of the software. Support group. I can do support group. The other piece of information that gets captured is build paths, and that's really annoying. It's where you actually type the make command gets into the final binary. File order might get captured. If you concatenate, you do concat star something, and then depending on when they were written in the file system, you get different results in the final build. I don't know. We can, yeah. Colin.
It's worth noting on build paths that those are a security co-location as well. Occasionally we find that people's paths in developers' home directories.
Yeah, now it's working.
Okay. Occasionally we find that paths in developers' home directories are hard-coded into packages, and that the package will care whether that thing under /home exists, so that's worth nuking for other reasons.
Yes. So for example, you have, Russ, you want to add something? Okay.
One comment on the timestamps. The one place where I do know that that is used is it's used by GDB when you're actually debugging a binary, so that it can tell you that the source file is newer than whatever went into the binary. I suspect there's some easier way of storing, or some better way of storing that timestamp than the build timestamp, but it is used there, I think.
I'm coming to the build, like I'm coming to the debug symbols. That's
okay.
Major headache. And so local, for example, get also captured. For example, the GNU sort command line utility will sort file differently depending on your local. Yep. So for example, so Gzip, to give you a couple of examples, Gzip by default will store a timestamp. Yay, super useful information. AR, tar, zip, jar, they all store timestamp. So and for Debian, I mean, most of them will store a timestamp that is pretty useless because this is the time of the build. It is you just like you've just created a new file with GCC and put them in an archive, and that timestamp is not really interesting. Javadoc writes timestamp in the health file. Why? So that's the major headache. So dwarf. So you have elf, and you have the dwarf, which are debug symbols. And so in dwarf, there's the build path of the source code gets captured, which actually is annoying because then it means that if you install the -dbg package in Debian, then the source path is not right. You can't, you have to fiddle with it. I'm coming back to that later. Go for it.
So we currently do builds inside of fake root. Perhaps we should start doing builds inside fake time or similar, and like always return the epic.
I'm coming to that.
Okay.
So for file order, we have readdir, which returns file in the order of the file system. So I mean, yeah. For local, so that's what I told you. Like sort varies between French and the C, like if you have an accented letter. But there's also other examples. Other information that might get captured: the host name of the system. Super useful in a built binary. Told you. The uname output. Well, for some cases, but really, I'm not sure. The username of the builder. No. So we could cheat. That's the way the Tor browser does it. They use a VM. That's the Gitian thing. The Bitcoin people also use that. They use a VM. So, and everybody who's building the thing gets the same virtual machine image. And so they have the same kernel, they have the same user, they have the same build path because it's basically the same file they share. And for example, they also use tools like libfactime, which affects the time. So that's one way to do it. The other way to do it is, and I think is more correct for Debian, because it's not, we do not craft our little solutions in our corner, but it also would be great if every free software distribution would have reproducible builds. So we fix the bugs, which I consider that in the build process capture some data that is not useful for the resulting software, then it's a bug in the build system. So for example, we can configure the toolchain. Binutils has an option that is called, when you do the // configure, enable deterministic archives, which will actually have the AR command not record user ID and timestamps. So that would make it the default. We need to patch software like Javadoc, so they get a -- no timestamps. And we could eventually, like, we can individually patch build systems, like changing the build system so Gzip has the -n option, which will not capture the name of the file in the timestamp. Paul?
So, just looking at this stuff, it makes me think of upstreams, and that makes me think of the upstream guide and the BOF that's coming up later in the week. And yeah, so we could add some advice for upstreams, and maybe, do you think the proper place to do this is fix the build systems themselves, like autoconf, CMake, or is it problems in the separate configuration for those?
So for example, Binaries is toolchain, so it's our responsibility. Gzip is often called when in the Debian rules when we do the main page thing.
So what about Javadoc? I was thinking mostly of that one.
Well, we could try to make Javadoc by default not store timestamp at all, but that's
True.
the fight with the Javadoc upstream. Yeah.
Right.
That's the fight we should put. But also there's something that more and more upstream are getting interested into being deterministic, their build system. Like I know that it's not much, but the HTTPS everywhere extension for Firefox is the build is reproducible. Well, it's pretty useless for Debian because the Debian package itself cannot be reproducible. Yeah.
Okay.
So in order to like toy with these ideas and thinking about also what Manage said, what we did is an experiment. By building and rebuilding many source packages, we used so the EC2 VM things. I'm not clear on the details, but David Suarez made all the magic happen, and thanks to him a lot. And so the idea of the experiment is we build the package twice, and to do so we set up a clean root, we unpack the source code, we install the build depends, we build, and then we do the exact same thing. One slight difference is that we pass the timestamp of the post build to dpkg through an environment variable. So in that context of the experiment, we make two variations. The time of the build is different because there's no lead effect time library or such. And the build path will be different because the build is done with sbuild, which will pick a random path every time you have a build. But there's no changes, no variations in hostname or username or uname, or I believe the file order because we unpacked the package the same way both times, or the local, which is I think C in both cases. But still, it is a pretty good framework to start evaluating. And so for the second experiment we made in January, so the changes from a normal Debian build environment system that we did was, so there's a patch for dpkg that uses a single timestamp for the whole archive. So the .deb, .deb are made of tar files. And so the tar files have a single timestamp. And we can pass to dpkg an environment variable that will make it write the exact timestamp in the archive. There's also sorting of the files that dpkg put in the archive, so we always get the same file order. And so to get to fix the build path problem in the dwarf files, we used the tool that was designed by Red Hat called debug edit, and which can change the paths in the written dwarf files after the build. And so we hooked that into a debhelper strip, gh strip, which also produces most of the -dbg package. So that felt like a good place to place it. But there's a trick that we need to pass the -f no merge debug strings to GCC, because otherwise debug edit can't work well because hash table order will get dumped, blah, details, painful, blah. And also Binaries has been rebuilt to have the enable deterministic archives. So that's the experiment we did. We built 5,151 source packages, and that produced 3,196 of them, we had produced identical binary packages. That's 62%.
Is there a rationale for the set of source packages you chose? Because I went to look at it to see what the state of mine was, and almost none of them were there.
No, they were picked at random by David's systems. So it is not actually like super representative, but it is to say that it's not a crazy idea. We can do this, and maybe getting to 100% is a crazy idea, or will take several decades. I don't know. But at least getting to, 80, 90% doesn't sound like unreachable goal. To give you a couple examples with that setup, findutils was reproducible, wget, calypso, busybox, Python support. So that's a couple of packages that they were working well. For the failures that we identified in the remaining packages, there were top failure is the dwarf file still having a mismatching build ID. So between the two builds, which probably is because the build path, so either the package is not calling the hstrip or the build path is encoded in a way that the trick we used didn't work. Yeah. So jar files, there was a problem in Haskell files, there was a problem in PHP registry capturing build path, Gzip timestamps, mono. There's something with mono going on. I don't know. There was dogbook to man, like a timestamp in there. There's a couple of other hanging fruit, like low hanging fruits that could benefit a lot of packages at once. But right now we still have no good solution for the build ID thing, the dwarf. So one idea that actually Stéphane Glandu came up on the reproducible main list is, okay, let's stop creating DH-strip weird things. How about we agree on a canonical build path? That will solve the problem Colin mentioned about random paths getting in the files. And also we would have GDB would have a canonical location, so it would be easier for Debian users to just apt-get source in the right location, and when they will run GDB, they will have the right path already set up for them. And there's a tool that is called proot that can actually fake the current directory of a software. So you could eventually build the software in whatever directory you want, run gpkg build package, and it will actually, in the background, like fakeroot does, fake the current directory so you get the canonical one. But we will change the sbuild and pbuilder, so they would use this canonical repository every time. Proot has downsides in that it uses Ptrace, so it's not available on all architectures. So that might be a problem, I don't know. But, and it's unclear how we push changes like that, or at least to me, if they're super old timers of Debian who tell me how we get to decide on the canonical build path. Please don't answer me, do a GR, but that would be an idea to solve that particular class of problem all at once. Another idea might be contentious would be to have dpkg build package export the environment variable Gzip, which are options for Gzip, and pass the -n option by default. Maintainers were not really happy when dpkg build package started to push C flags and all, so maybe this is contagious, but it would solve also a lot of packages at once. So I don't know. Yeah.
It seems like that would fall afoul of a number of upstream build systems that go out of their way to not be affected by environment variables like Gzip that you may have set as a user.
Well, then you can fix them individually, but we can swipe a lot of apples at once if we did that. That's, I don't know. Russ had a question?
Sorry.
Or comment?
Hey, I'll get fit.
Is it possible to strip the timestamps out of Gzip compressed files even if they were originally compressed without -n as a post-processing step? Because if so, you could just throw something in the deb helper that goes through all the compressed files in the package and just removes the timestamps.
Good idea. I don't know if that's such a tool, but that might be easy to write actually.
They're easy to strip out, so yes, we should do that.
Okay. Huh. Interesting.
I had an answer for the default build path that was not a GR. So user SRCs should be read-only according to different policies I could read. And pbuilder throws stuff in var cache, so maybe that could be used instead. And I had a question regarding the timestamp. When you fake a timestamp, which time do you choose?
So so what it is, so if you do a first build and you capture the build environment, you capture the time of that build environment, and that's what we use to like as a reproduce point on when we did write the .deb of the second build. But
Of the start of the build or the end?
no, well, the time, whatever. It's using the same. It's using the time at the start of the build right now. But the point is, I mean, libfake time has become really powerful. You can actually record all calls to get timestamp of the day, and have it replay them. But I don't think that's the way we should do it in Debian. I mean, we could also agree that why it is done that way is actually to please Guillem Yover from DPKG, because the initial discussions were, I want to keep timestamps. That's what he said. So maybe, I don't know, maybe we have to go to the technical committee to say, okay, it's not useful to have a timestamp in the .deb archives at all. Yeah. So I'd like to, yeah.
Yeah, question on that. So that's good enough for the use case of us testing that packages are reproducible, but I think the other use case is enabling user to reproduce the exact packages which are in the same archive to ensure that we are not making anything fishy. So how do you imagine that? We produce the packages and there is a way to extract the packages for the user to apply?
So
replay, sorry.
So I have a couple of crazy ideas, but can I like go back? Okay, cool. So just to finish, I wanted to make a new experiment using DPKG build package I would call proot. But David Suarez was too busy, so couldn't. I'm really sorry. I would have expected something like 80%. But I don't know, maybe 90%, I don't know. There's other distribution interesting to that. So there's Fedora, who's had like one of the security people writing a blog post about this after we started the Debian initiative. To the best of my knowledge, there has been no further progress in that. OpenSUSE has something interesting called build compare, but I hadn't like time to look a lot about it. And the distro called NextOS is super interested into reproducible builds because they have an interesting system where they capture they already captured the environments that was used to build a specific package and its dependencies. And so if they get reproducible build, then it means that when you upgrade a specific package, you have to rebuild far less. Because if a build dependency hasn't changed but hasn't changed its behavior, then the checksum at the end stay the same. So there were like interesting cross collaboration, but it's so far I'm under the impression that the main efforts on this have been like in the Debian crowd or friends. So, okay, before I get to want to help, crazy ideas. So one thing, first, there's this idea that we should not directly pick dead binary packages that are well built on developer system and put them in the archive. We're getting there slowly, like Ansgar worked on DAC to move forward on this. What I'm advocating is actually we make so developers are forced to build binaries. So then we add the .deb, and so the .changes file contain a checksum for the .deb, right? And you upload everything to the upload queue except the .deb. And then you have a build-d that would pick that changes and all the afferent file, rebuild the packages from source in the same environment, and if the .deb actually that is being produced match the original checksum, then it gets in the archive. That idea, so that means sparing all internet connections, which would be good, but also it means that then you have reasonable trust that your system is not compromised, or the build is not at the same time as the build is compromised. That's, but yeah.
Of course, you do have a problem with multi-arch and different architectures with that, because most of your developers will only have one architecture to play with or two. So you only got faith that the architecture that your developer has uploaded for hasn't been compromised and not a sub-architecture.
Yeah, sure, but we have general trust that the build are not easy systems to compromise, or we try our best so it's not the case.
We can also have multiple buildees in multiple geographical locations and cross those.
There's one here.
In addition to just having multiple build-ds, you could also have the standard build-d system work as is now, and then other people who want to run reproduce build-ds can still pull the same things from Snapshot and attempt to reproduce these and then verify that for themselves, if they wish.
But so my main focus, like to answer Zach's question, my main focus is the .changes file. I want .changes to be the basis of reproducing a given build. Then we could even go more crazy, is that currently changes files are signed by only one developer. We could have .changes files that are signed by multiple keys. So we can trust even more, spread the trust to have more trust. So that's an idea. So if you want to help, that's one of the things that I really would like to make this experiment that I hadn't had the time. As every large-scale build experiment, what takes time is also to sort the results. So if you want to help, we have a nice tool that is called diffp. That takes two .changes file, and we'll run a lot of crazy tool and tell you differences by diffing many file formats inside the .deb. So that is people like triaging bug. That's one thing. Yeah, Paul.
Just quickly on the changes and the multiple signers. That makes me think you need detached signatures from the changes file.
You don't actually. You can have multiple signatures in the same block.
So you then modify the changes file when someone else signs it?
Bike shading. Let's go on. We can find a solution. Currently we have no. So my point is we need to put every single piece of information that is useful to reproduce a build in the .changes file. Maybe that's not the best way to do it. So there's research to be done there. So that's one thing, and we need someone that would specify something.
So we could record information and then replay it later, but that effectively means that if you build in the absence of that build log information, you get a different build. I think it would be more valuable if we construct a standard environment so that if two completely independent builds occur, they will get the same result without any logged information that needs replaying. And that doesn't seem infeasible for most of the problems that you've mentioned.
Yeah, that's so 10 minutes left. That's trade-offs here that might not be super easy.
Any such standard environment would be constantly evolving because your build dependencies are constantly moving under you. But there are various tools that exist today. DH Build Info, I think, is one such that do log this kind of thing, and maybe we should just standardize in one of those.
Yep.
So not sure if this is going to derail your talk, so I'm sorry. Have you guys seen anything where it builds multiple versions of the same binary and then tests to see which one performs best and then ends up using that one? I seem to remember there was something with Firefox maybe that did that. What is it? PGO. PGO? Oh, yeah, right, exactly. Have you seen that, and are there techniques to avoid that?
No, not yet. Well, I know that Firefox can be made reproducible because the Tor browser is based on Firefox, and so there has been the need to stomp random bytes, 3 bytes that are like zeroed because nobody could get a clue why they were written to the binary at some point, but it's doable. So if you want to help specify, that's worked here, and we need that as well. If you want to code, then there's a lot of no timestamps option that needs to be added to software. Or if you want to do politics, you can also, once that code is written, try to convince that it should be the default option. And also, we are still missing a script that would you give it a changes file and maybe a recurrent environment in the changes file or in other file. I don't know, maybe in the DH build info file. And it would fetch the correct dependencies version from snapshot, set up that in pbuilder or sbuildroot, and run the build. That would be an awesome thing to do. We know it's doable. No one just got to it yet. It's probably a weekend project. And there's project management to be done here. There's a lot of baby steps to move forward to the goal of reproducible builds. I would love someone that is not completely full with so many things to just, ask me once in a while. I'll ask anyone interested in, hey, what are you going to do about reproducible build this week? And I can tell them, yeah, I will look at this package. And maybe I will not, but at least I will some I don't know, some kind of peer pressure, just okay, what is we need to do next? During the last hack time, Ashish just told me, do something about reproducible build, and I've sent a patch to DH Python that took me half an hour to write. So this is a lot of small things that can be done. If you want to stay in touch with the project, so there's the Reproducible Builds wiki page, subscribe to it, and there's also a main list. And that main list is used as a user tag in the Debian BTS to record every bugs we've reported so far as part of the project, and we had very good reactions from a lot of maintainers who promptly took the patch and that added a -n to Gzip or added sorting things to get a cyber-stable order. So yeah, there will be a buff. So that's why I was cutting some of the questions. There will be a buff right after dinner to discuss technical solutions. So we have 45 minutes more to try to, sort out the fog and make plans so we can get to total world domination. So we get to reproducible builds. So yeah, that's my end of what I had to present so far. I want to give credits to, so Stéphane Glandu has to work at some point, he's not here, and David Suarez, and a couple of other people who actually really got interested in the Git thing, and not just tell me, yeah, this is great. So, and please, this is not something that I or even 2 people will fix alone, and this is an issue for the whole Debian and free software community, even as a larger group. So let's do that.
Just on that, maybe we can expose these problems to the developer community as a whole via the package tracking system. The new tracker is relatively easy to contribute if you know Python and Django, so that would be really helpful if someone could add a way to look at that stuff.
So one thing we're missing right now is a set of standardized, or at least the beginning of standards on what is the way to reproduce a build. Like what is the environment, or where do we store the information? Because right now it's been ad hoc experiments, and so I can't say, well, yay, bonus point, your package is reproducible, because I don't know what that means yet. We need to decide on something here, or just get to some code that will decide, but at least there's nothing currently. I would love to have something like an infrastructure like ci.debian.net that would actually be just trying to reproduce packages. But we're not that yet. We're missing a few steps. Any other question? Is this crazy? Is this a waste of time?
No, that's great. Yes and no.
Okay, troll me.
Okay, so this is kind of an insane idea for the future, but like you were talking just now about having something like ci.debian.net. It would be cool if we could put that in like an AMI or something, so we could have this like distributed trust, so that anyone who wanted to could. That's like an Amazon machine image. So anyone who wanted to could like run some sort of continuous integration thing, and you'd get like if the Debian infrastructure got pwned, then someone else would catch it.
Then you only have to have the AMI.
Yeah. That's Rust. We have only 1 minute left.
We need reproducible AMIs.
Well, there's another project Paul started, which is called reproducible installs. Look at the wiki page. There was Rust, and that build last question.
So on the comment of being able to reproduce this, I think that if we're going to talk about having developers upload reproducible builds that we can verify then in the reproducible build environment, that really means that we need to be able to document exactly how you set the whole thing up to generate a build of this type, which means you get essentially that for free. And I think that it's probably better to have the detailed documentation in the specific set of tools than it is to have it all as a machine image anyway, because that way you can verify each step of that. And given that one of the goals here is security verification, that gets more trust in the entire process. And it also allows for the various variants in workflow, because different people like to use, Cal Builder versus LVM partitions or S build instead of P builder, all that kind of thing.
Well, my goal would be like it's in dpkg, and you do dpkg build package -- rebuild, give it a change file, boom, and you can do that on any Debian system. That would be the best user experience on reproducing builds that I would love to get. We'll see how far. I think we're at that time, so I will thanks everybody who came and who's supportive of that thing. Come to the BOF if you want to do shit. Thank you.